This is a really fun project. I enjoyed making this months ago. I wanted to basically visualize physics here, and always pretty intrigued. When I thinking in calculus or sort of rates and think about velocity in space, I've always wanted to kind of see a tracer of what my velocity is at any given location. So this is what I call velochrome, or velocity tracers, color velocity chasers or tracers or something like that. So what's happening here is I'm moving this this sphere around. This is the movable ball actor, and as I press in a certain direction, I'll increase the speed, and as I do, the tracer color changes from blue to red, and I've got this ramp here. You'll notice that it doesn't change a whole lot, just going up in the air and falling. Right now it's the speed, which is the magnitude of the three-dimensional velocity vector. So that's like the overall change in distance across all three dimensions. But with the change of, if I right-click and hit Edit Code, the code here, which interestingly is just 2 lines of code. If I just change, instead of getting the linear velocity's length, the magnitude, and I just say get the linear velocity in the y direction, I'm now going to change this color based on how much my sphere is changing in the up and down direction. And if I roll around on flat Earth, it doesn't change color at all. And when I start rolling up, it changes, it goes up in the sort of blue towards purple towards red part of the spectrum. And when I come down, you'll see it gets kind of green, because I'm now traveling down pretty quickly. And so up goes blue, green comes down. And so those are like either side of the kind of that level point of bluish green, blue going up, green coming down. So a lot of fun things you can do really quickly with this, and we are going to build this from scratch. So I'm going to make a new show. I kind of like the horizon of summer midday, kind of enjoy the brightness of it. So I'm going to work in that. The first thing that we're going to do is build 2 spheres. One is the actual movable ball, and then the next one is the thing that it's emitting. It's going to emit this object behind it that is a replica of itself, but it's not going to be an object with a rigid bodies. It's just going to be this kind of ghostly, kind of sphere tracer that I'm going to emit a lot of, and then you'll still be able to roll through it and pass through it. So first we're going to have an actor. We're going to put the movable ball in the space, draw it at any height, or draw it, to any size, and then double click it. We're going to come up here to the sphere shape. Double clicking any object, if it's not a unit, if it's just a single object, we'll open up properties, and then go straight to the shape. That's the fast cut to coming here, expanding mesh model, and grabbing the shape. For this one, we're going to make the radius 0.5, and we're also going to make the tracer ball 0.5 as well, but we'll do that in 1 second. What I want to do is, on this movable ball, we're going to crank up power to 30. That's our ability to accelerate. That kind of gives us a little bit more responsiveness from our key presses. And then I want the maximum speed to go from 15 to 18 meters per second. And that 18, it's not a huge deal, but that'll make our math just a little bit easier for translating. And I'll show you why when we get to that part of the code. So now we're going to build the thing that this sphere is going to roll around and emit. And we are going to build the thing that it's going to emit. Notice that it's up in the air now that I changed its size. I'm going to bring it back down to the ground in stop time so that it doesn't fall each time. So let's go entities, sphere. So the first sphere was the actor movable ball. The second sphere is going to be a regular sphere. And since they have the default material on them, they're going to look basically the same. And I'll come up to the properties of this sphere and make its sphere shape radius also 0.5. So now I have a replica of this sphere to leave behind. To make it ghostly, by that I mean that I can pass through it like kind of like a ghost passes through a wall, or you might pass through a ghost, or ghost might pass through you. We're going to get rid of the rigid body so that we're not colliding with these things that we emit. So we're going to actually click this triangle here and remove the attribute. It's basically similar to turning the rigid bodies active to false, but in this case, it actually ends up taking up a little less data and space. And if we want to emit a lot of these things, we might as well make them as sleek as possible. You can even get rid of this trigger activating attribute because we're going to emit potentially hundreds of these, and we don't need all that information. Okay, so we're going to be trimming down the thing that we emit. The most important is to get rid of the rigid body. And so now let's just try to emit this. So we're going to place an emitter. You can place it anywhere in the space, honestly. So we're going to, this emitter is going to travel with our movable ball. So where the movable ball goes, the emitter is going to go with it. And since we're dealing with a sphere, rotation won't matter. And so we can just put this node emitter directly on our movable ball. So by grabbing the words node emitter and drag them up onto the movable ball here in the hierarchy. And now my node emitter will go wherever my sphere goes. But it's kind of poised off to the side. It's not in the center. And of course, it's not emitting the thing that we want it to emit yet. So let's fix both of those. First, let's get the node emitter dead center on our movable ball. So the way to dead center anything that you've childed to something else, bringing it under the hierarchy, is to zero out its transform, and that'll send it to the origin of the parent node. So now our node emitter lives at the 0, 0, 0 of its parent, the movable ball, and it's now in the dead center, which is great. That's right where we want it. Now let's set the sample of the node emitter to be this sphere here in the space. So select the node emitter, make sure you select on the top object, scroll down on the left side and get down to sample. We're going to go to use the picking tool here. So we're going to press pick, and then we're going to pick the movable ball here, or sorry, the sphere entity. So this is our you can select it here. You could also select it there. But now that we've done that, our node emitter should be emitting these spheres. Since they don't have a rigid body, they don't roll, and they don't come out with any physics on them. They just stay behind. They just roll right behind me, and I'm emitting them in this 1 per second kind of pulse, and that's clearly not desired. So let's actually crank up our speed, and then we're gonna tune this a little bit later as well. But right now, let's crank up the pulse. This is what's driving the emissions, and it's this constant pulse. And when you click that hyperlink, it opens up the tab of the constant pulse, and we want the frequency to be how many times per second should we emit this? Like 1/10 of a second might be a good example, and we'll take a look. So every 10 times a second, we're going to emit one of these spheres. And you'll notice one thing, that the faster I move, right, the more spacious they become, or the more gaps appear between them, which is pretty cool. In one sense, I do like that. It shows that I was kind of moving faster there. I was covering more distance per every 1/10 of a second. And that's pretty cool. That visualizes velocity just right there, right then and there. But I think we're going to use a different way to emit these that might basically get rid of those gaps and allow us to kind of have a continuous stream of these objects. And so that's what's the node emitter's moving property. So we can emit by a continuous pulse, and or we can emit from a pulse and or a moving driver. Like if the emitter gets moved, it's going to emit a certain number across the amount that it's moving. And this is not per second, this will be per meter. And so if we say none here, so what you want to do is turn off the continuous pulse by hitting none, or another option is to select constant pulse and hit inactive. I'm going to recommend doing that just in case you want to come back to this constant pulse. So we're going to set it to inactive. And now, just to demonstrate, I'm going to press the space bar to play and roll around, and we don't see anything happening, which is what we want. So now under the node emitter properties, we're going to come to moving. And on the emit rate, we're going to say, let's try 10 per meter. And this is a meter in any direction. In any direction, I will put 10 nodes in there. So you'll see that basically the tail size stays pretty fixed at a total length of 2 meters. That's because I can only have 20 in the space. So that's the max simultaneous. That's how many spheres can be out there. That's 10 for the first meter, 10 for the second meter. And I want a longer tail than that, and we can afford it, depending on how strong your computer is. It can max out at higher numbers, but you'll be safe with these low polygon primitive objects like a sphere. So you'll be safe to go all the way up to 100. So let's just work with 100 as our max simultaneous. And so now our tail is more like 10 meters long because we emit 10 every meter, and so we end up with this 10 meter long tail. Okay, so this looks pretty cool. We've got this tail chasing us. Feel free to change the max simultaneous amount or the fade values. Fade is how long it takes to fade in and out, yeah, so those could give you, maybe you want the fade, for example, fading in time to be 0. That way it comes in at full opacity and then fade out over kind of a long arc. That might be something you want. I'm going to work with that actually. And lastly, I'm going to actually turn down the emit rate just a touch. I'm going to cut it in half actually, down to 5. And that gives us just a little bit more gap between these, between each of these steps. Okay, so now comes the scripting part. We've kind of constructed stuff. We've got our tail ready to be a chaser. And let's now do the script. So basically what's going to happen is we're going to say, every time I emit, I want to change the color of this source object. So one of the tools we're going to use is a function on the emitter that is an event called onEmit. And when we click on emit, this happens every time it emits, right? So 10 times, whether it's every bit driven by a pulse and it's some unit of time, every 10th of a second, or every 10th of a meter traveled, or every 5th of a meter traveled. It's going to emit this object and run this function right before it emits it. So this function has an argument called obj, and that is the object getting emitted, which is this sphere entity. So whatever the node emitters, I'm going to pin the node emitter so that we can come back to it regularly. So whatever the node emitter's sample is this obj. So the end line that I'm going to have is the end line of script is going to be obj.color equals something, equals some value. And so now I need to get basically a velocity value from the movable ball. So the node emitter is right here in the middle. It's saying Well, I know what I'm going to emit. It's going to be this OBJ. So we can tell it to color it. I just need to get a hold of my parent node and get a hold of its the linear velocity, which is through the rigid body. So we're going to do that right now. So node emitter wants to get its parent node. So we're going to say node emitter, matching this. Actually, excuse me, we don't need to do that. We're going to say self, colon, get parent node. And now that parent node is this movable ball. So we're going to get that movable ball's rigid body, get rigid body, open close parentheses, colon, for the next function. And then we're going to get the rigid body's linear velocity, get linear velocity. And we have the linear velocity, and that's a three-dimensional vector, which is interesting, but it's not the equivalent of what we think of as velocity, which is really speed, which is the magnitude of that velocity, which is a one-dimensional value. So that's the speed, and the way to get that on any three-dimensional or any vector is an internal function on Lua called length. And that's the length of that vector, the magnitude length of that three-dimensional vector, no matter which direction it's pointing. It's an always positive value. So we're going to store this in a variable. So we're going to call this vel for velocity. Is going to be the magnitude of the linear velocity vector that's found on the rigid body on the parent node of self, the node emitter. So node emitter, movable ball, rigid body, velocity, length. And that's going to be vel. And so now we need to set the color based on vel. But before we do that, let's take a look at making sure we have vel. So we're going to use the print statement, print, open close parenthesis, and then we're going to say toString, lowercase s. It's an internal function and it doesn't follow camel case. Open close parenthesis, and that we're going to turn vel into a string so that we can print it. And we should see the printout happen down here as we emit. So we're starting to see our velocity values. I moved our speed values, really. I moved 2. As I move around more, you can kind of see them. They get up to about 18. I see it maxing out at like high 17s. And so, which is true to form, because that is, if we select our movable ball, if you recall in the beginning, we had set our max speed to 18. So that's, we are seeing that speed getting printed out here, and it does indeed sort of max out at about, right about 18. So now we know what our values go from. They range from 0 to 18. And we're going to set our color value using the hue value. And we've got a support document called Scripting Clipboard at support.simmetri.com under the Scripting Makes You Magic. And if you go down to color, there's a whole bunch of different ways to set color in script. And one of those is with RGB values. Another, which I find much easier to use in this case because it's a color becomes a one-dimensional value, is HSB. So hue, saturation, brightness. And we just want to vary the H of that. Otherwise, we could change the amount of red in some value, but it's kind of confusing as to how I'm going to sort of transform a one-dimensional speed value into a color. And I kind of want the color to kind of change, fluidly along this curve. So I'm going to use this HSB function, which HSB then is open close parentheses. Inside of it, I'm going to pass in 3 values. So hue, we scroll out here, Hue goes from 0 to 360, so that's like a red at 0 up to all the way through the colors back to red at 360. Saturation, we're going to go full saturation, so we're going to make 1, saturation will be 1, and then brightness at 1 is typically means that's like basic brightness, but it could go, you could make it glow if you put in some value greater than 1. So with that, we'll return to symmetry. So HSB is what we're going to work with. And I'll put open close parentheses, put 2 commas in the place, and I'm going to say I want full saturation and singular brightness, or like brightness at level 1. And I want a hue value, so I could just say vel, and that's going to go from 0 to 18. And let's actually take a look at that. And you're going to see something funny. You're saying, oh, well, it all keeps changing colors. So I tricked you. One of the issues is when we emit, if we are emitting what's called a shared copy and not a full copy, all of those items that come out, all of those emitted items, that'll be 100 of them total, they're all going to share a color property value. And we don't want that. What we want is for each sphere that comes out to have its own unique color. So let's, instead of making it a shared copy, make it a full copy, which means that it has its own color value. It doesn't share any properties with the other clones of this, and see what we get here. Now we're getting these individualized colors, and they don't change. So when that's red, it stays red. When it's light yellow, it stays light yellow. So that's now that we see that the color changes, it's easy to realize we need to do one more thing on the node emitter. And to recap, that was change clone as to full copy. By default, it's a shared copy, which is computationally less expensive because it says just kind of make a replica, a sheer replica of me. Again, if it's a shared copy, you'll see them all changing at once. And it's either all yellow or it's all red, because each one of these objects is going and referencing this source object. And what we want to do is not make it a shared copy, a copy that shares values with its clone source. We want it to be a full copy. And so now when we move around, there it is. Cool. So now we're changing color based on our speed, and that's pretty cool. And the color is not all changing at once because we are emitting a full copy. We're cloning as a full copy, not a shared copy, and we're looking pretty good. Maybe you do like this color pattern. A lot of people tend to say, oh, I want it to be a cooler color or darker when it's slower. And so now we just need to do a little bit of math and create kind of an offset so that we get somewhere in the spectrum where we go from cool to warm across some value range. So our values of speed are going from 0 to 18, and I made it 18 because we're going to work with the second half of the hue spectrum. Let's take a look at the hue spectrum just as a little reminder. For some, it'll already make sense. So, hue lesson. On this sphere's color, I'm going to put on what's called the color components attribute, and that allows us to break open the color into HS and B, into hue, saturation, and brightness. And here's where you can kind of visualize this. Let me crank up the saturation. So 0 is red, 360 is red. It goes through this spectrum. First it goes to yellow, or to orange, yellow, and green. And then right at about 180, it's blue. And then from blue, from 180 up to 360, it goes through the purple back to a red. And so the way I approach this is I said, if I want it to go from blue to red, I need to start at 180. Then I need to, at maximum speed, I need to get to 360. And so if my maximum speed is 18, I have a pretty easy job basically saying, oh, take my velocity times 10 and then add it to 180. So if my velocity is 0, times 10 is 0, plus 180 is 180. And if my velocity is 18, multiply it by 10 will get us 180, add it to 180, and we'll get 360. So we're going to set that up. I'm going to delete this sphere. And we're going to set up that logic right here. So object.color equals HSB. We have vel in here. I'm going to do a bunch of parentheses to sort of set this up. So what did we say? Velocity times 10. So times 10. So when it's maximum, that'll be 180. That'll be 18 times 10. And then another set of computations. I'm an over parenthesis here. Sometimes I do it just to break apart and be sure of my order of operations. And then I'm going to say 180 plus this value. So when velocity is 0, it's 180 plus 0. So that'll give us 180 in the hue, which will make it blue. And when it's 18, this will be 180 plus 180, which will be 360, which will be red. Now this should work. There we go. And we're still printing, so I'm going to actually get rid of that. I'll right-click on the node emitter where our code lives and edit code and comment it out with 2 hyphens. It'll turn green to let you know. And now we're no longer printing. And tremendous. We've now got our velocity tracers, and when we travel at full speed, we get red. And you can have kind of a lot of fun with that. Another thing you might do is to, right now we are, our node emitter is going and getting this object as its source. And sometimes it makes sense to be like referring to this object in the space, but you might also want to stick this object in the library and refer to it there. Then it doesn't have to live in the space. And I'll show you how to do that. What we're going to do is select the source object, just our sphere entity, not our movable ball. We're going to right click and we're going to hit add to library. And you'll notice that it shows up here in the library now. And now on the node emitter, if I open up the node emitter and I have my sphere entity node open here, on the node emitter sample property, I can drag this sphere entity onto that value. And now instead of this node emitter referencing my in-world object, it references this library level object, which means that I can delete this sphere and my node emitter keeps emitting because it's talking to this sphere. And the next thing you might be able to do is say, oh, it's kind of specular, it's kind of reflective. Maybe I want to change kind of the material property of my emitted sphere. So let's actually do that. Let's take this sphere entity up in the library, the thing that's getting emitted, and we'll open up Mesh Model and go to Materials. And let's make a new material for this one entirely. So we're going to say New Standard Material, then we're going to select it. And we want to make sure that the diffuse color source is material plus object color. And we're going to make the material color black because we don't want any color coming from the material. We want it just on the object color. And that'll give us the same effect that we've been having, but now we have a fully new material other than the default material, which you could call, for example, that standard material you might think of as the tracer material. And so if we wanted to, we could mess with this translucency value. Now it's a bit more like a translucent chaser. Maybe we don't want it to, we don't want our sphere entity to cast shadows. So we'll turn that off. And now the tracers don't cast shadows. You can still see that they're glinting in the sun. Maybe we do want that. Maybe we don't. Let's see if we can turn that off. So we'll come back to our sphere entity and travel to its material. And let's turn the specular level down to 0. And now we're no longer getting that, that glint. Let's change the translucency to additive and see what we get. And this basically looks pretty cool. Additive kind of works in this way where if you bundle them in the direction of the camera, they will kind of add up brightness values. That's kind of cool looking. Of course, you could also do alpha blended. I don't know how much we like it, but it's another possibility for translucency. I'm going to stick with additive for the time being. Additive looks pretty kind of ghost-like and almost like particle style. Then you might be tired of just rolling around on the flat ground. So maybe you want to put some terrain in and raise up a hill on the terrain. Then you can kind of maybe roll around on the hill. You can see it kind of pick up speed as it rolls down the hill, as it changes color. Let's make a steeper hill here. There we go. That hill. There we go. Very cool. So you could do things that are kind of build some physics lessons around this, and or some cool visuals. You could connect this to a VR controller, or you could put multiple of these in the world, multiple objects like this. If you used the interactions like grabbable, you could grab this in VR and toss them around. You could make them bouncy and bounce them off of walls. You could also emit this object if you wanted, which would be interesting. I can actually turn off this. I can remove the movable ball attribute. Now it's a normal sphere that you might toss in the air, and then you could emit this object. So if I went to emitters, put another emitter in the space, and now I'm going to sample this movable ball, which has an emitter sampling our library's tracer. So I've got node emitter, new node emitter. I'm going to take this node emitter and I'm going to sample. I'm going to pick our movable ball. I'll pick it right here in the hierarchy. And now I'm going to, and I'll crank up the physics on this one. Node emitter physics. I'm going to emit at 18. I'll put a little arc on this guy. You can see the computer's starting to get a little slower, which means that you might want to do a few things. One, this node emitter, maybe I only want to put 10 in the space at any given time, because now I've got 10 of these objects times 100 of their tracers. So I'll maybe make the tracer value a little bit lower, 50, and maybe make the emit rate just a little bit smaller. And now maybe it won't be as computationally costly. What is this node emitter? There you are. Transform. Cool. So you go. You can kind of see how you can build up some fun stuff pretty quickly. The last little trick I'll show you, and we can do it here from this emitted. It's kind of emitter of object with the emitter situation. Is what if we don't want it to be the overall speed that we're using to color this object? What if we want it to be the amount of change in the y direction? And this we did in the beginning. If I edit the code, I can actually, instead of saying length of this velocity, I could say, what if I want the y component of that linear velocity? So if there's a change in the y direction, either up or down, I want that to be the what drives my color. It threw an error on vel. Get linear velocity vel equals. Should work. It's a capital Y I put in here. I had caps locks accidentally hit. This needs to be a lowercase y. There you go. There we go. We almost got a velocity rainbow. Let's emit fewer of these. Let's take that down to 3. So what you can see here is that this value goes, changes as it. Let's bring it down to the ground as well. So, for example, you'll see all this variance in color as it increases its speed, and then once it's traveling on flat ground, it's no longer changing its y. And you'll notice that, interestingly, and this is what your calculus teacher tried to teach you, it has basically the same change in y over change in time in effect here at its peak as it does when it's rolling on flat Earth. And that checks out, and you can see that chromatically here. Pretty cool. So that is a pretty fun project. I'll be excited to see what anyone does with it and where they take it. And yeah, look forward to more.